Okay, ladies and gentlemen, here we go. We're going to do some complex numbers in De Moivre's theorem. Now, this is an easy thing to do, but it's going to look nasty. So you might as well buckle up and be prepared to remember a few formulas and a few patterns, and if you do, it'll be quite easy. So here we go. If you'll remember correctly, we have complex numbers. A plus bi. Nothing crazy about that. 2 plus 3i. 2 is the real part. 3i is the imaginary part. Now, you'll also remember that we can graph imaginary numbers. But imaginary numbers are graphed on an imaginary plane. Instead of the x-axis, you have the a, or real axis. And instead of the y-axis, you have the b, or imaginary axis. So if you have an imaginary number, the old math joke goes, where would you put it? On an imaginary axis. So, here we go. If I have 2 for my real number, I move over 1, 2. If I have 3 for my imaginary number, I move up 1, 2, 3. This is something you've done at minimum in Algebra 2, if not in geometry as well. That's where it is, 2 plus 3i. Not terribly shocking, not terribly creative. Real axis, imaginary axis, over 2, up 3. Now, our chapter is a chapter on polar coordinates. And just like our old buddy x and y, if I have a and I have b as the components, can't I also figure out what it would be to represent this point using polar by simply finding the radius from the origin and whatever the angle is from the x-axis? Using that type of information, I can find a polar coordinate. Now, how would you find r? Well, if I have a right angle, not shockingly, r is going to equal the square root of a squared plus b squared. Should look really familiar, but remember these are not x's and y's because they're not real numbers, they're a's and b's. So, how in the world would you find this angle? Well, gee, I think the tangent of that angle would equal whatever's across from it, b over what's adjacent to it, a, or theta equals tan inverse of b over a. Now you should begin to see why they put it in this section and in this chapter, because you're using these same old formulas again. Now, unfortunately, just like we don't represent imaginary coordinates as 2, 3, we represent it as 2 plus 3i, we also are not going to represent complex polar coordinates as r, theta. It's going to have its own form. Its own form will be as follows. Okay, we go from a plus bi, which is rectangular, to this guy, r parenthesis cosine theta plus I sine theta in parenthesis. This is the polar version of this. But folks, it shouldn't be terribly shocking. Just like r is equal to a squared, square root of a squared plus b squared, we had a formula that said x equals r cosine theta. Well, in this case, it's not x and y, it's a's and b's. And a is first, so this is like a equals r cosine theta. And b, therefore, would be r sine theta. So if I simply took a plus bi, it would be r cosine theta plus, and I'm going to put the I up front for clarity, r sine theta. But there's an r in each place. If I factor the r out, I get r out front, cosine plus I sine theta. And that's where this form comes from. Now, your homework to start a few problems is to convert the following. 6 plus 2i, 4 minus 3i, and negative 6 plus 2i. Now, ladies and gentlemen, graph these out, because when you do the inverse tan, you could get potentially the acute angle or the obtuse angle, and you don't know which one you're going to need unless you have it graphed and to see what kind of angle you're really talking about. So that's the first three problems on your homework. Now, if you'll remember, when we have complex numbers, 2 plus 3i, 6 plus 2i, we can add those complex numbers with very little difficulty. 8 plus 5i. We could subtract them with very little difficulty, and that would be negative 4 plus 1i. That's not a big deal. To multiply, we would have to indeed FOIL. Now, first, outer, inner, last. So we have 12 plus 4i plus 18i plus 6i squared. Now remember, I equals root negative 1. So I squared would be square root of negative 1 squared. They cancel. I squared equals negative 1. So that's negative 1. That's negative 6. So I get 6 plus 22i minus 6. Oh, so yeah, so you get 6 plus 22i. That is multiplying. Now for dividing, we had 2 plus 3i divide by 6 plus 2i. To divide, we actually had to do something a bit different. We had to multiply by the conjugate. So we had 6 minus 2i, 6 minus 2i. And when we do that, we have to actually FOIL the bottom and FOIL the top. And so you'll notice dividing becomes a real bear. 12 minus 4i plus 18i, and then again minus 6i squared. Down here, I come up with 36 minus 12i plus 12i minus 4i squared. The middle terms cross out. This turns into plus 4, and you get 18 plus 14i all over 40. Tends to be long. That's using complex numbers. If we change them to polar form, it's going to be a real bear. So we would have r equals the square root of 2 squared plus 3 squared, and theta equals tan inverse of 3 over 2. Okay, I've gone and done a little bit of the work for you. Took this number here, found its r, its radius, root 13, using a squared plus b squared square root. Theta equals inverse tan of b over a, and you get 56.3, which means, putting it in polar form, 13 parenthesis cosine 56.3 plus I sine 56.3. Again, r equals, and then I took 6 and 2, 6 squared, 2 squared, that'd be 2 root 10. Tan inverse of b over a gives me 18.4, so 2 root 10 cosine 18.4 plus I sine 18.4. Now, if I wanted to multiply those two together, that's what it's going to look like. If I wanted to divide them, that's getting crazy. If I wanted to square them, up here is no big deal. To square this, I would simply FOIL it times itself. Same thing could happen down here. However, if I wanted to take the square root, cube root, fourth root, or a root of any sort of this number right here, it cannot be done in this form. Doesn't exist. So that's why we actually have to do polar form. you're going to find that in polar form, it's going to be very quick, very easy, and it's going to be worth the trouble to convert it. But we'll talk about that in class. You have your 3 problems that you need to convert to polar imaginary form, and then we'll talk about everything else in class.